Good morning, friends. Now we are solving numericals in game theory of module number 5 in operation research. So, solve the following matrix given. So, here player A is having 4 course of action, player B is having 5 course of actions. So, the matrix given here, the payoff matrix is written for the player A. That means player B chooses his first option and player A is choosing his first option. The score is -2 to the player A. Suppose the same matrix is written for player B, we are writing with the same numbers but with opposite signs. Instead of -2, we are using +2. Then instead of +5, so for player B it will be written as -5. So okay, the matrix shown here is the payoff matrix for the player A. That is, both of them are choosing their first option. The score is -2. That means the score to the player A is -2. So at the end of the game, the player A is taken as the winner and player B is taken as the loser. It need not be mandatory that in all the trials the winner is going to win the game. So in some trials the player B also win the trials, but the final outcome is that the player A is declared as winner. That is, the person who wins the game is named as player A. The person who loses the game will be termed as player B. Now we have to take here minimum in each row, the score. So here the first row, the minimum score out of these payoffs is -2, right? -2. Second row, the least score is 1, right? 1. In the third row, so the least score is -4, right? -4. So fourth row, the least score is -6. Now out of these 4 values, I have to take the maximum one. But because player A wants to maximize his gains, out of these minimal values, choose the maximum one. So 1 is maximum. So maxi min value. So coming to player B, first choose the maximum values column wise. In the first column, the maximum value is 5. In the second column, the maximum is 3. In the third column, maximum is 1. In the fourth column, the maximum is 5. In the fifth column, the maximum is 6. Out of this, choose the minimum one. So though the player B loses the game, he wants to give minimum score to the winner. So out of these maximum value, choose the minimum one. So mini max value, that is 1. Now compare maxi min and mini max. So if they are equal, we say that saddle point exists. If maxi min is equal to mini max, we say that saddle point exists. So that itself is the value of the game. So value of the game is 1. It is having plus sign. That means the game is favorable to player A. So now this 1 is chosen in the second row. That is the player A is having his strategy number 2 as the best option. Similarly, this 1 is existing in third column, that is column number 3. So player B's best option is the third option. So this is now the saddle point where mini max is equal to maxi min. So value of the game is equal to 1. Then next problem, we have 3 strategies for player A and 4 strategies for player B, and this is the payoff matrix written for player A. If the same matrix is written for player B with the same numbers, the signs will get changed. If it is plus here, it becomes minus. If it is minus here, it becomes plus. Now go for minimum values row wise. In the first row, the minimal value is 1. So write 1 at the end of the row. Similarly, in the second row, the minimal value is 4. Write 4 in the second row. Then third row, the minimal value is 0. So write 0. Out of this, choose the maximum one. So that is A wants to maximize his gains. So maximin value, that is 4. Similarly, column wise, first you write the maximum values at the end of each column. Take the minimum out of it. Because B wants to minimize his losses. He wants to lose the game to player A by offering minimum score to him. So here the minimal value out of this is 4. So value of the game is 4 now. We say that the saddle point exists. Value of the game is equal to 4. Positive sign. That means it is favorable to player A. So this 4 is existing in second row. That means A2 is the best option for player A. Similarly, column wise, if we go, so 4 is existing in the third column. So B3 is the best option to player B. Then third problem, we have 5 strategies for player B and 5 strategies for player A. Some of them are positive and some of them are negative in the payoff values. So this is the matrix written for player A. If the same matrix is shown for player B, the signs will get interchanged. Minus becomes plus and plus becomes minus. So row wise, take the minimal value first. So first row, the minimal value is minus 12. In the second row, minimal value is 0. In the third row, minimal value is minus 8. So that is circled. In the fourth row, it is minus 11. In the fifth row, it is minus 7. So row wise, I am circling the minimal values. Then column wise, I am boxing the maximum one. So 8 is maximum, box it. Then 12 is maximum, box it. 0 is maximum, occurring at 2 places, box them. So then 10 is maximum, fourth column, box it. Fifth column, so 20 is maximum. Now I want row wise, out of all the minimal values, choose the maximum one. So that is this. Out of all the maximum values column wise, choose the minimum one. So that is 0. So where box and circle are meeting each other, so that is the value of the game. So that is 0. We say that saddle point exists. Strategy best to player A is A2. Strategy to player B is B3. Thank you, friends.